x squared plus 3x gives me my function. Okay, so I hope that's pretty straightforward. I hope that was easy. Okay, number 4. I kind of did these out of order for some reason. I think I'm going to skip these. So number 4, use the graph of the integrand and areas to evaluate the integral. Draw a sketch and show your work. So the sketch is important. Make sure you label it. Don't use a calculator or antiderivatives to evaluate the integral. Use only areas, and the integral was from -5 to 3 of 2x plus 4 dx. So this is easy. This 2x plus 4 is just a straight line. So I graphed that, and I did that one down here, so I'll show you. Oops, let me get this out of the way. So if I graph this line, the slope is going to be 2. And I didn't try to do it quite to scale as far as the slope's concerned. But you can see that y equals 2x plus 4. That was the function. I'm taking the integral. So I'm going to use this to evaluate this integral. I guess I could write it over here. The integral from -5 to, let's see, 3 of your 2x plus 4 dx. All right? So your intercept is 4 and your slope is 2. So there's my intercept. When x is 0, y is 4. And then I go, my slope is 2, so I'll go up 2 over 1, up 2 over 1, etc. And we want to find the integral from -5 to 3. And you can see this off your practice test. So there's -5, there's 3. So it's a straight line, so I can find these coordinates. And when x is 3, if I put 3 in here, 2 times 3 is 6, plus 4 is 10, so y is 10. So my point 3, 10 is here. And you notice that we have 2 triangles. This is real easy to evaluate. One triangle is above the axis, so that value will be positive. That area will take the positive when we're evaluating the integral. And this triangle is below, so that area will take the negative of that when we're trying to evaluate the integral. And at this point it goes to -5. And if I set this equal to 0, if I set 2x equal to 2x plus 4 equal to 0, x equals -2, that's where it crosses the x-axis. So this is -2. So we can figure out the area of these 2 triangles quite easily. And again, over here at -5, if I want to find the point here at -5, which is the left limit of integration, all I have to do is put that -5 in my equation. If I put -5 in here, 2 times -5 is -10. -10 plus 4 is -6. So this is the point, -6. So the altitude of this triangle is 6. It's in the negative direction, so that's 6. And this is 3 because I'm going from -2 to -5. And then I'm going from 2 to 3, so this is going to be 5. And if I go from from 0 to 10, that's going to be 10. So the area of this triangle, if you look at it, if you sketch it, take a look at how I sketch it, it should make sense. The area of this triangle is going to be 1/2 base times height. The base is 5, and the height is 10. So 1/2 base times height, 1/2 of 10 is 5. 5 times 5 is 25. So the area of this triangle is 25. And this triangle is going to be 3 by 6. So here's 1/2, 3 times 6. 3 times 6 is 18. Half of that's 9. But it's negative because it's below the x-axis. So the actual value of my integral is the net area. And the net area is positive 25 above, 9 below, so -9. So 25 minus 9 is 16. So that's actually the value of the integral. The net area, which is 16. Okay. So if that makes sense, you make sure you have to draw a sketch and make sure you label everything. So show these points, show your triangles, you'll be in good shape. Hope those help.